All right, so here's a bit of a primer on the carbon and climate change issue. Let's sort of try to make sense of the big picture. Generally, with the groups that I've given this presentation to, it tends to be a lot more of the agricultural producers that are more in tune with what's going on with the process. So let's sort of go over some of the issues early on, some of the terms, get everything down path. Then we'll start talking a little bit more about the sequestration science, and then finally finishing up with more of the recognition of the work that's going on right now. So a little bit of information about me. My name is Richard Boulding. I have my honors degree in geology, and I have submitted my master's thesis. So hopefully in the next little while here, I'll be getting more information back on that and possibly a new shiny piece of paper. Some of my work background, I've actually taught with the University of Regina in environmental geology and soil science. I've worked with the government of Saskatchewan with the Saskatchewan Geological Survey. I've also worked with the Royal Saskatchewan Museum and with the Peace Region Paleontology Research Center. So let's start with a little bit of the background here. First, let's ask the question, what is climate change? So it's any significant change in measures of climate lasting, and this is the important part, for an extended period of time. So we're looking at this more in terms of decades to millions of years. Some of the things we look at when we're looking at climate is we're measuring the temperature, the precipitation, wind patterns, and other effects. Now, climate is this large dynamic system, and it just so happens that temperature, precipitation, wind patterns are easier for us to measure. So they're sort of looked at as symptoms of the overall system. So climate change is not to be confused with global warming. Every now and then you get the odd politician that will try to use the two terms interchangeably. They are related to one another, but they are definitely not the same thing. So what is global warming? So it's a rise in global average temperature near the Earth's surface. It represents only one aspect of climate change itself. And this can be caused by variations in solar output, so the actual output of energy from the sun, variations in Earth's orbit. So we tend to think of our orbit around the sun as this nice sort of perfect circle. Actually, it's a lot more elliptical. So there are times we are closer to the sun and times that the Earth is farther away. It can also be caused by increasing concentrations of greenhouse gases in the atmosphere. And the recent global warming that we've been seeing has been related to these greenhouse gases. Now, how do we know this? If it was related to the solar output or to orbit around the sun, we would see warming or cooling trends in the upper and the lower atmosphere. Whereas in the case of the greenhouse gases and what we're seeing right now, we see warming trends in the lower atmosphere and cooling trends in the upper atmosphere. So that's how we know that it's related to the greenhouse gas concentrations. And of course, global warming is causing climate patterns to change. So now we have to answer the question of what are these greenhouse gases? So they're gases that absorb and re-emit radiation, particularly in the infrared range. So that includes energy that comes in, it hits the Earth, and then some of it is actually re-emitted in that infrared range. And these greenhouse gases actually trap that energy in the atmosphere and cause these warming trends. So when we're talking about these greenhouse gases, they're not some evil thing. If we didn't have these greenhouse gases causing this warming in the atmosphere, the Earth's average global temperature would be about minus 18 degrees Celsius. So when we're talking about these greenhouse gases, we're talking about water vapor, carbon dioxide, methane, nitrous oxide, ozone, and CFCs and HFCs. So that's chlorofluorocarbons and hydrofluorocarbons. Freons are part of that. Generally, when we're talking about these greenhouse gases, you're always hearing about CO2 and carbon. To sort of streamline the process, they like to talk about everything in terms of its equivalency to CO2. So the ability of CO2 to trap that infrared energy, methane is able to do it at a rate 25 times more efficient than what the CO2 does. And with nitrous oxide, it's able to do it 298 times more efficiently. And with the CFCs and HFCs, 675 times and 14,800 times. So as we can see, we like to look at these in sort of their equivalency. So 1 unit of methane would be equal to 25 units of CO2. 1 unit of nitrous oxide would be equal to 298 units of carbon dioxide. So that's what we mean when we're talking about carbon overall. We just sort of look at everything in terms of its equivalency to the CO2. Now, in 2014, 35.9 gigatons of CO2 emissions were released into the atmosphere. And when we look at the CO2 concentrations in the atmosphere, they've now reached over 400 parts per million after being only 280 parts per million in 1750. Now, why is that 400 an important number? Last time we were around those CO2 concentrations in the atmosphere was during sort of the start of the Pleistocene. Now, another question I get is, how do we know this information about what the atmosphere was like back in 1750 or even farther back in geologic history. A lot of the more recent information on the atmosphere we get from ice cores. Going farther back, we have to use other techniques like looking at geochemistry to figure it out. The conditions in the atmosphere also affect the conditions that form particular types of rocks. So based on the chemistry of those rocks, we can start to tell more information about what sort of the chemistry of the water in the atmosphere was like at that time. So we talk about all these greenhouse gases, so we have to ask, what exactly is the problem? What's going on with them? They're causing increasing temperatures, especially in continental interiors in the northern hemisphere. And what is in the continental interior in the northern hemisphere? The Canadian prairies. We're seeing altered precipitation patterns, greater precipitation in other areas, and drought conditions in other areas where normally they wouldn't see these types of events going on. We're seeing an increase in extreme weather occurrences. So events that used to be a 1 in 50 year type event, say maybe a flooding event, now we're starting to see these things on the scale of even 1 in 10 years. Another aspect we're seeing is the melting of polar ice caps and sea level rise. So to sort of get an idea of how much water is still held in ice caps, glaciers, and permanent snow cover, there's over 24 million cubic kilometers still held within that. So suddenly if that water becomes available to the ocean, seas, and bay systems, we're definitely going to see an even greater rise in those sea levels. Another problem we could see is the melting of the permafrost, which it's estimated currently holds 2 times the amount of carbon currently in the atmosphere. We're also seeing the acidification of soils and oceans. And when you start to do that, you actually start to release the carbon that's currently held in the soils. And as well, oceans are a much larger sink for carbon than we originally thought. When you start to increase the acidity, you start to impact the life in those oceans. This is the same area of coral reef in less than 5 years across. So you can definitely start to see the impact that it's having on the ocean life. We can also start seeing changes in oceanic currents. So currently there are areas around the globe that do see warmer currents, so they are experiencing sort of more temperate conditions than what they normally would based on their latitude. For example, Europe is one of those areas. So changes in those oceanic currents could actually start overall change the climate that these areas see. One of the biggest problems we're going to be seeing here, especially in the Canadian prairies, is the migrating habitat boundaries for problem species and diseases. So certain things that we used to think as being primarily states problems, as we start seeing warming more in this area of the continental interior, some of those pests and diseases could start migrating northward into us. So after all that doom and gloom, here's a little bit of a positive side to the increased carbon in the atmosphere, something called the carbon fertilization effect. So it's basically the idea that the more atmospheric CO2 you have, it'll actually drive forward the process of photosynthesis. One of the things we're starting to see now is actually a shrinking of the stoma on leaves of plants because it's easier for them to intake CO2 from the atmosphere now. And as sort of a side effect of that, there's less water loss going on through the stoma. So that means that plants are effectively becoming more able to survive in these arid type conditions. So with the carbon fertilization effect, we are seeing documented increases in the amount of photosynthesis going on, but it is highly dependent on soil moisture and nutrients. So areas where soils might be more heavily leached or they might be older soils, they might simply not have certain nutrients like phosphorus to take advantage of this increased CO2. And of course, this increase in the photosynthesis does not make up for current emission levels. Now on the side here, I have this graphic. Generally, one of the arguments you'll get from groups like geologists is, what's the big deal? CO2 levels have been higher in Earth's history, so why is this a problem for us? Well, us as humans, we have not existed through all of Earth's history. And so I sort of bring forward this idea of a global thermometer. At the bottom end of the thermometer, we have this 7.2 degrees Celsius, so that's the average global temperature during the last ice age. Then we have 25.9 degrees Celsius, which is believed to be the highest average global temperature recorded in geologic history, more recent geologic history anyways, back around the Cretaceous period. And here we have this bubble that I called human climate. So this is sort of the range of temperatures that humans have evolved under and we've lived under as a species since we've started to exist. So when we look at 150 years ago, the average global temperature was about 13.9 degrees Celsius. Today, it's 14.9 degrees Celsius. Then looking forward to the year 2100. So this 21.7 degrees Celsius average global temperature, that's a high carbon scenario. That's sort of, we don't do anything about our current emissions. We just sort of leave things be and let the process happen. The 15.6 degrees Celsius, that's a low carbon scenario. That's where we start buckling down and sort of worrying about our emissions, curbing things, and sort of looking for alternatives for energy. So as you can see, even in a low carbon scenario, we're actually pushing beyond those limits of what our species has existed under, sort of since the time that we evolved. So that sort of starts to make us wonder about, will this start to stress the human system itself? The idea that yes, the Earth itself will be fine even with the rise in global temperatures, but humans themselves might not be around. So what are some of the proposed solutions? If you talk to environmentalists, you might get the answer of, let's turn off the engines and unplug all the power. Now, if you talk to an economist, they say, let's put a price on carbon. So that's the idea of, if you make something more expensive to do, people are going to want to do it less and less, and they're going to look for other options to sort of reduce how much it's going to cost them. So overall, you hear about these carbon tax and cap and trade systems. So a carbon tax is a tax on the greenhouse gas emitters. It increases over time to encourage the greenhouse gas reductions. It's easy to implement, and it's a stable carbon price. We already have all these taxation systems already in effect. It's as simple as just sliding another one onto the pile. However, the decrease in emissions is uncertain. You can make it more and more expensive to do something, but if an individual can keep paying more and more to keep doing what they're doing, sort of won't give that incentive for them to reduce their greenhouse gas emissions. Now, it is supposed to be revenue neutral. We will get to that a little bit later. There's also the cap and trade system. So it's where you put a cap on emissions for large emitters. If you go over that cap, you have to pay. If you are under that cap, you can sell your access to other companies that may be going over their cap. That cap is set to decrease over time, so it does encourage the greenhouse gas reductions. Dealing with the carbon offset system, if you don't use what is within your cap, you can sell that to another one that's going over. So this is where we deal with individuals that are sequestering carbon, in particular agricultural producers, and they can get carbon offsets for how much carbon they're putting into the ground and sort of sell that to companies that will need those credits. However, the prices in a cap and trade system are subject to a volatile carbon market, as we've been seeing in sort of California. With the system, we do see guaranteed emission reductions. So sort of a bit of a history of putting the price on carbon in Canada. Back in 1997, we signed the Kyoto Protocol. We agreed to a 6% total greenhouse gas reduction below 1990 levels by 2012. Then later in 2009, we signed the Copenhagen Accord, where we agreed to a 17% reduction from our 2005 levels by 2020. In 2010, we also signed the Cancun Agreement, but we sort of reiterated what we said in the Copenhagen Accord anyways. And then finally, in December of 2011, we became the first signatory to announce our withdrawal from the Kyoto Protocol. Now, why did we do that? The Kyoto Protocol itself was binding, whereas the Copenhagen Accord is not binding. So in the case of the Kyoto Protocol, if you did not reach your reduction targets, there was sort of something not pleasant coming your way. Then in 2016, we signed the Paris Agreement, where we agreed to cut our greenhouse gas emissions by 30% below 2005 levels by 2030. Now, if you look, this is actually sort of the same thing we promised in the Copenhagen Accord, just sort of on a longer timeline. Then in October of 2016, Canada announced a carbon pricing scheme with a minimum introductory price of $10 per ton rising to $50 per ton by 2022. Then looking forward beyond that to November of this year, we have COP23 in Bonn, Germany. It's going to be hosted by Fiji. And this idea is going to be put forward of an international price on carbon. So it's sort of getting everybody on equal footing and taking that idea of competition out of the picture and dealing with the issue of carbon. So looking at some of the current carbon taxation systems in Canada, in particular, British Columbia has a carbon tax. It started at $10 per ton in 2008 and has increased to $30 a ton in 2012. And as said, it will remain at $30 a ton until the rest of the country gets on board. It is administered to fuel wholesalers, and there's a trickle-down effect to consumers. So generally, as fuel becomes more expensive, everything else just becomes more expensive. And of course, the carbon tax is supposed to be revenue neutral by law. So that means how much extra people have to pay out in carbon tax. There's supposed to be that much of a reduction in other tax areas. And what the Fraser Institute found was that certain reductions in taxes that were put in place before even 2008 were being counted against the total reductions to sort of offset what the carbon tax was. The study found that once reductions are taken out of the picture, BC taxpayers have forked over $226 million additional dollars in increased taxes in 2013-2014 and $151 million extra in 2014-2015. Now moving over to Alberta, they have sort of a hybrid system. In 2007, they brought in a cap and trade on high-intensity emitters. So that was anybody who emitted over 100,000 tons of CO2 per year. And it's aimed at a 12% reduction. Then finally, in January of 2007, they brought in a $20 per ton tax on fuels. And it's supposed to increase to $30 a ton starting next year. Now, of course, when talking about the taxation, we also have to talk about exemptions to the carbon tax. In British Columbia, there was no exemptions for agriculture prior to 2014, but afterwards, an exemption was granted for farm fuel, as well as propane used by qualifying farmers for farm purposes. Also in 2014, an annual rebate of $200 to northern and rural homeowners was granted, and an 80% rebate for greenhouse growers. Now in Alberta, marked fuels are exempt from the carbon tax. And as well, it was announced that $10 million in programs would be given to help farm operations reduce their emissions and save on energy bills through efficiency upgrades. Now, looking at the greenhouse gases in Saskatchewan and our emissions. So Saskatchewan accounts for 10% of Canada's greenhouse gas emissions, with only about 3% of the population. Agriculture itself in Saskatchewan accounts for 16% of our province's emissions. So when you look at sort of how it's divvied up, oil and gas accounting for 34%, agriculture 16%, electricity 21%, and we also have to keep in mind that a good portion of that electricity is actually being used in oil, gas, and mining. And of course, the agricultural emissions are in the forms of carbon dioxide, methane, and nitrous oxide. So we have to ask the big question now, what could this cost me? So Scott Moe, the Saskatchewan Minister of the Environment, on March 3rd, he attended a luncheon in Moose Jaw, where he gave the estimate of about $10 to $15 per acre at a $50 per ton carbon tax. Now, this is without any exemptions put in place. And sort of the second after he announced that number, I started poking them to sort of find out how they got it. So this was based on farm fuel consumption in field operations based on fuel usage from the Provincial Crop Planning Guide, as well as agriculture energy excluding farm fuel in the forms of natural gas, electricity, propane, and other fuels. This also looks at the costs that would be applied to fertilizer and pesticides, both from their production, packaging, and transport to the farm gate itself, and of course the costs that would be associated with grain transportation from the farm gate to the port. And that's sort of looking at the average fuel consumption from looking at on-road and on-rail travel. As well, at the IHARF Soil and Management Seminar back in February, a Dr. Mario Tenuta from the University of Manitoba, he gave the estimate of about $19 for a $50 per ton carbon tax. And again, this is without putting any exemptions into place. Then at the Canadian Federation of Agriculture, also later in February, a Dean Hubbard, who was a member of the Carbon Panel, and he's a farmer from just outside of Claresholm, Alberta. He has been very meticulous with his farm operation and has actually calculated that since his operation moved to zero-till in 1995, he has doubled their soil organic matter. And even with the current exemptions in place in Alberta, he estimates that the carbon policy will raise his costs by about 6% this year. Now, when we look at those numbers and we start thinking of a 6% increase in costs, we take a look at the Canadian net farm income and gross revenue, adjusted for inflation. So when we're looking at this figure here, we see this blue line representing the gross revenue, and then we see the green representing the net farm income. The net farm income is a small percentage of the overall gross revenue. So when you start looking at 6% in additional costs, we start seeing what could be considered a good year turning into an okay year turning into break even, and years that you would normally break even, you'd be in the red. And of course, unlike other commodity groups, producers are unable to pass on this additional cost, meaning it's going to come directly out of their already thin profit margins. So then we start talking about agriculture and how it is actually part of the solution to the carbon emissions. So let's start out with the APAS official stance. APAS believes governments need to recognize the unique impacts of policy proposals like carbon taxes on the agricultural sector, including the negative impacts on our ability to compete internationally and the potential disincentive to produce food that the world needs. APAS does not support the imposition of a carbon tax on fuel and other agricultural inputs. So when we're looking at sequestration that's going on in Canada, we have to actually look at how much land is in crop and how much land is in pasture of the Canadian total. In particular, when we're looking at Saskatchewan and Alberta, over 70% of the total land in crop and over 70% of the total land for pasture is found within these two provinces. So if you're going to be talking about sequestration that's going on through agriculture, these two provinces are definitely the ones you have to look at in terms of what's going on with sequestration. So let's start out with the cropland side. In particular, let's talk about the Prairie Soil Carbon Balance Project. So it was initiated in 1996 to determine how much carbon could be sequestered on agricultural land. A benchmark study was initiated looking at 143 fields across the province, and this is supposed to represent all the possible combinations you could get of soil and landform types. Now, 8 additional sites were selected for sort of a side-by-side comparison, with one field being done with zero-till and the other field being done with conventional tillage. And what was concluded from this study was that using zero-till is allowing growers to sequester 8.75 million new tons of CO2 every year. So this equates to about 0.38 tons of CO2 per acre sequestered yearly because of the use of zero-tillage. So again, with the SSCA, there is a carbon advisory board and a lot of the commodity groups that are involved in it. And we'll look at some of the SSCA positions on carbon. So they are firm believers that if emitters of greenhouse gases are penalized through a carbon tax or some other form of system, then those who are removing greenhouse gases through carbon sequestration or capture should be compensated to equal measure. They also believe that the government should follow the Vancouver Declaration commitment to enhancing carbon sinks, as well as establish a pan-Canadian offset protocols framework to allow for the verifiable carbon credits and that they could be traded internationally. They also believe that work should be done to determine the management practices that will maximize carbon sequestration in hay and pasture land, and the annual sequestration rates for these different soil types and under various weather conditions for the grass. They believe that we need to understand carbon emissions in the atmosphere when some tillage is required on fields that have been zero-tilled for many years or decades. Again, farming is a very dynamic system, so it makes sense that the policy needs to be equally as dynamic. They also believe that there needs to be a focus on research on nitrous oxide emissions in a manner that ensures effective use of fertilizer to maintain production with minimized emissions. They also need to understand the impact of pricing on agriculture inputs and understand that Canada's climate change plan needs to include an export sensitivity process to both understand and calculate the impact of carbon pricing on the competitiveness of Canadian exports. So sort of looking forward at some of the other research that's going on around the world towards increasing productivity and sequestration on cultivated land, in particular, look at Stephen Long's work out of the University of Illinois. He's managed to increase the efficiency of photosynthesis in modified tobacco by up to 30% and increase the yield of the experimental crop by 14 to 20%. Now, some of you might be thinking, I'm not growing tobacco. Why should that bother me at all? Tobacco is one of the easiest plants to modify genetically. So that means that tobacco is effectively the proving ground for a process that could be applied to other crops. We also have to look at the work by Douglas Kell out of the University of Manchester, who's calculated that breeding crops with roots extending to 2 meters depth instead of 1 meter depth will effectively double carbon sequestration and make them more drought resistant at the same time. So when we look forward to the future where the world's going to need 70% more food grown by 2050, it's sort of research along these lines that may potentially help us get there. Now let's take a look over at the livestock and grassland side. So sort of looking at the livestock production efficiency and how it's increased, from 1981 to 2006, greenhouse gas emissions per kilogram of milk have declined by 35%, and from 1981 to 2011, greenhouse gas emissions per kilogram of beef animal have declined by 14%. So we can definitely see that the work is being done. Now looking at the actual carbon storage on grasslands, it's estimated that uncultivated grasslands in Western Canada contain as much as 2 to 3 billion tons of carbon to a depth of 1 meter. And when we're talking about a $50 per ton carbon tax, that definitely shows how much value needs to be placed on these grasslands in terms of their storage. Gray's Natural Grasslands function as a net carbon sink due to improved management practices, as well as net carbon sequestration of soils on these grasslands. On the black soils, about 0.22 tons of carbon per hectare per year. Dark brown soils, 0.14 tons of carbon per hectare per year. And the brown soils, 0.09 tons of carbon per hectare per year. When looking at some of the studies involved with carbon sequestration on grasslands, the breaking of mixed grass prairie and immediate planting of perennial grasses led to no change in total carbon after 13 years. However, continuous wheat cropping led to a loss of 19% of carbon overall. They lost about 1.7 tons of carbon per hectare per year for the first 4 years and 0.32 tons of carbon per hectare per year for the next 9 years. The big point to underline here is that once that carbon is lost, reestablishing that soil organic carbon is a very lengthy process. In particular, there's one study here that looked at native mixed grass that was broken and then revegetated, and even after 50 years, it did not reach the same levels of soil organic carbon that the original native grass prairie held. So looking at carbon sequestration from management practices themselves, evidence suggests that grazing may increase root biomass and hence the amount of carbon sequestered. So looking at particular in that study, the ungrazed versus slightly grazed, moderately grazed, and heavily grazed, in that particular case, they found that the heavily grazed actually increased the root biomass the most and hence the amount of carbon sequestered. Now, these types of practices are going to be highly dependent on the type of soil you have and sort of what moisture regime you're looking at. If you have more of a sandy type soil, it's going to be a lot harder to bounce back from that heavy grazing versus more of a loamy type soil. It's also been found that the digestion accelerates the nitrogen turnover or mineralization in the system, which can also potentially stimulate plant growth and carbon accumulation. So now that we've talked about a lot of the research involved with the carbon sequestration, and we know that work is being done by these agricultural producers to sequester this carbon, now we should start to talk about the recognition of this work. One of the things we want to do is the Agricultural Carbon Summit put on by the Agricultural Producers Association of Saskatchewan. They believe that agriculture is playing a significant role in sequestering carbon on the landscape and has the potential to play an even greater role in providing the solutions to carbon and greenhouse gas emissions. So the Carbon Summit is set to bring together producers, researchers, policymakers, and other communities to discuss agricultural innovations, policy recognition, research, and knowledge gaps to be addressed. It's to be held July 13th and 14th at the Saskatoon Inn, and if you want to get more information on it, you can check out apascarbonsummit.com. Thank you very much for taking the time to listen to my presentation here, and hopefully we will see you at the Agricultural Carbon Summit.